Hey guys, we are going to get started in chapter 7 today, starting with lesson 7.1. We're going to be talking about all different types of polygons, focusing mostly on quadrilaterals in this chapter. So today we're going to just start talking about angles of a polygon. All right, let me present my screen and we'll get started. All right, so we do have a little bit of vocabulary to first take care of. All right, so first diagonals. Okay, so diagonals of a polygon is a segment that joins two non-consecutive vertices. Okay, so if I was to draw a polygon, we'll call it A, B, C, D, E. All right, so this is polygon A, B, C, D, E. Polygon A, B, C, D, E. Okay, and if I wanted to draw a diagonal, all right, just pick one of the vertices, doesn't matter which one, I'll start with A. And it says a diagonal of polygon is a segment that joins two non-consecutive vertices. Well, the vertices that are consecutive to A are B and E. But if I draw a segment from A to C, that would be a diagonal. And A to D is also a diagonal. All right, so A and B and A and E are consecutive. All right, so again, B and E are consecutive to A because they're right next door, but C and D are not. So drawing a segment from A to C and A to D would create two diagonals. All right, I could have also chosen B to start with. Okay, consecutive to B would be A and C, but I could draw a diagonal from B to D or from B to E. Okay, I could choose C. The diagonals from C would be C to A and C to E. If I choose D, the diagonals would be DB and DA. If I choose E, the diagonals would be EC and EB. Okay, hopefully that makes sense. All right, next, equilateral polygon. We've learned about equilateral triangles. All right, the equilateral triangle, what do you know about equilateral triangles? You know that all sides are equal. So it's the same thing with an equilateral polygon. All sides, oh, that's an S, are congruent. All right. Equiangular polygon, just like an equiangular triangle, all three angles are equal. We take 180, divide by 3. We know each angle is 60. So in an equiangular polygon, all angles are congruent. All right. And finally, regular. That word is super important when you read in a problem or the directions. If it says it's a regular polygon, that word regular is telling you something. Okay. It means that it's both equiangular and equilateral. Okay. So regular polygon is equiangular, equilateral, meaning all sides are congruent and all angles are congruent. Now, the formal definition is it's a convex polygon that is both equilateral and equiangular. All right. Okay, polygon interior angle theorem. The sum of the measures of the interior angles of a convex polygon are n minus 2 times 180. Okay, this is a formula that we do need to know, okay? If you think about it, we have a triangle. What do the interior angles of a triangle add up to? Angle 1, 2, and 3. We know they add up to 180, right? So for a triangle, the interior angles add up to 180 degrees. What if we have a four-sided figure? Well, what I'm going to actually ask you to do is to draw the diagonals from one vertex. So pick a vertex, doesn't matter which one, and draw the diagonals. There's only one diagonal to draw from that vertex. How many triangles do you create? You create two triangles, one triangle, two triangles. So for a four-sided figure, if the interior angles of this triangle add up to 180 and the interior angles of this triangle add up to 180, I'm going to take 2 times 180 to get 360, right? And we could keep going with this idea. So if I draw a five-sided polygon, all right, and if I tell you to pick one of the vertices and draw the diagonal. So again, pick whichever vertex you want. I'm going to draw all the diagonals from this vertex. How many triangles did you create? 1, 2, 3. So again, 180 for this triangle, 180 for the interior angles of this triangle, and 180. So for a five-sided figure, you would take 3 times 180. So let's think about this for a second. For a four-sided figure, it was 2 times 180. For a five-sided figure, it was 3 times 180. What's the relationship between 3 and the five-sided figure? What's the relationship between the 2 and the four-sided figure? Okay, well, what you did was you took the four sides, you subtracted 2 to get 2, right? There were two triangles, and you took 2 times 180 to get 360. Okay, so that's what we did for our four-sided figure. For our five-sided figure, if there are 5 sides, you subtract 2. That equals 3. Remember, we saw that there were 3 triangles. And then you do 3 times 180 to get the interior angles of a five-sided figure. Okay, so that's where this formula comes from. N stands for the number of sides. However many sides the figure has, you subtract 2. That's how many triangles you would break it into if you were to draw all the diagonals from one vertex. And then once you know how many triangles, you multiply that by 180. Okay, so again, this is to find all the interior angles with the sum of all the inside angles add up to. All right, so for this example here, it's a six-sided figure, 1, 2, 3, 4, 5, 6. That also means there are 6 angles, 1, 2, 3, 4, 5, 6. So you would do 6 minus 2 times 180. Okay, well, 6 minus 2 is 4. 4 times 180. Now, again, where is the 4 coming from? What does that have to do with this problem? Well, if you pick a vertex, such as this one, and draw all the diagonals, how many triangles do we have? We have 1 triangle, 2 triangles, 3 triangles, 4 triangles. So you take your 4 triangles and multiply by 180 to get the interior angle sum. Okay? All right, so hopefully that makes sense to you. We're going to do some try these problems. It says, what is the sum of the interior angle measures of a 17-gon? Okay, so 17-gon just means 17-sided figure. All right, so we're going to have 17 minus 2, times 180. Follow order of operations to do your subtraction first. So 17 minus 2 is going to give you 15. And then 15 times 180 is going to give you 2,700. So all the inside angles add up to 2,700 degrees. Okay. Well, what do you think we need to do if we want to know what each interior angle measures? All right. This is talking about a nonagon. But let's actually think about the 17-gon for a second. If there are 17 angles and all of them add up to 2,700, let's pretend that that figure is regular, meaning that all the angles are congruent to each other. What would you have to do to figure out what the measure of each angle is? If they're all the same, there's 17 of them, and we know it adds up to 2,700. You would divide, hopefully you're knowing this, you would divide by 17. So you take the sum and you divide by the number of sides or the number of angles because they're the same. So in this case, you would take 2,700 and divide by 17, and you'd find that each angle is approximately, I'm going to have to round here, 158 point, we'll say 82. Okay, so each angle is approximately 158.82 degrees. All right, so we just came up with our next formula. You're first going to find the sum. So that's the n minus 2 times 180. Then after you know the sum, you're going to divide by the number of sides or the number of angles. So this is your next formula, okay? So make sure you highlight it, star it, put a box around it. All right, this is what you're going to use if you're asked for each interior angle of a regular polygon. Regular, that means all angles are the same. So for a nonagon, we need to know what n equals. A nonagon has 9 sides. All right, so I'm going to have to do n minus 2 times 180 divided by n. Okay, so n minus 2 is 7. So we have 7 times 180 divided by 9. All right, do your multiplication and then your division. Okay, so when you multiply, you're going to get 1260 divided by 9. And then when you divide, you get 140. Okay, so each angle is 140 degrees for a regular nonagon. All right. One thing that I should have done at the beginning is gone over all of the, I'm going to go back up to the top for a second. Hopefully, if you have maybe some room up top, we should have gone over the names of our polygons, the most common ones as well, or as at least. So number of sides, that's your n, and then name. We'll just kind of make a quick chart for ourselves to review. So what do we call a polygon with 3 sides? We call it a triangle. What do we call a polygon with 4 sides? If you said a square, that's one type. Rectangle, that's a type, right? Parallelogram, that's a type. Kite, that's a 4-sided figure as well. Rhombus, those are all types of quadrilaterals. So quadrilateral is any 4-sided figure. 5-sided figure is a pentagon. All right. We have a 6-sided figure, which is a hexagon. 7-sided figure is a heptagon. 8-sided figure is an octagon. 9-sided figure is a nonagon. Hope I have room for all the ones I wanted to write. The next one, 10-sided figure is a decagon. 11, we could write it. I'm just running out of room. 11 is an undecagon. 12, probably the most common one that you're going to see, which is a dodecagon. After 12, I'll do a little squiggly. After 12, if it's like 13 sides, we call it a 13gon. 14 sides is a 14gon. 15 sides, 15gon. Okay, so after 12, I'm just going to write n, and then it would be n-gon. So again, if the figure had 27 sides, I'd call it a 27gon. Okay, so these are definitely the names of the polygons that you should maybe probably already have memorized and be familiar with. If you maybe didn't know 1 or 2 of them, maybe you didn't know 9 is a nonagon, 12 is a dodecagon, just make sure you're familiar with them. So when you read a problem, you know how many sides the figure has, okay? Because that will be important for these problems. All right, let me see what else. Just have a little bit more. Oh. Okay, so we have a corollary. It says the sum of the measures of the interior angle of a quadrilateral is 360. Okay, so that is one of our corollaries, which again, we could figure out. A quadrilateral has 4 sides. So if I want to know the sum, that's at n minus 2 times 180. So I'd fill in 4. 4 minus 2 times 180. 4 minus 2 is 2, and 2 times 180 is 360. Okay, so I'm just illustrating how they came up with this 360. Also, if it's a four-sided figure, remember, you can go to one of the diagonal or one of the vertices and draw all the diagonals. There's only one diagonal. So you have two triangles, and that's why we do 2 times 180, okay? So that is a fact that you should know. You really shouldn't have to use the formula to figure that out. You should just kind of know that a four-sided figure, the interior angles always add up to 360. All right, so with that information, let's try number 3. It says, what is the measurement of angle G in the quadrilateral? Again, you just kind of basically need to know at this point that the four angles of a quadrilateral, add up to 360. So I'd say the measurement of angle H plus the measurement of angle E plus the measurement of angle F plus the measurement of angle G equals 360. That's based on the corollary above. Then I'd use substitution, 53 plus 85 plus 120 plus my unknown. You can leave it as measurement of angle G, or if you want to use a variable, you could like put X or Y. All right. So when you combine your like terms and then subtract, go ahead and take a minute and do that on your own. I'll give you a few seconds. So combine your like terms and then subtract it to the other side. You should get a measurement of 102. Okay, so 102 degrees. All right, I'm sure you're probably already familiar with that type of problem. That shouldn't be new. All right, now we're going to talk about the exterior angles. The sum of the measures of the exterior angles of a convex polygon, one at each angle, and that's important, the one at each angle, is 360. Okay, so for your exterior angles, it doesn't matter the shape. We could be talking about a triangle, quadrilateral, pentagon, hexagon, octagon, it doesn't matter. All the exterior angles are always going to add up to 360. But let me show you how to draw your exterior angles for just a moment. I'm just going to draw a few figures. Okay, so the easiest way to draw your exterior angles is pick a side and extend it in one of the directions. So what I mean by that is either trace it and extend it up or trace it and extend it down. I'm going to trace it and extend it up. This is an exterior angle. Now I'm going to keep going around the figure doing the same thing. I'm going to move clockwise. So I'm going to extend this side. Here's another exterior angle. And then the last side, here's your third extended angle, or your exterior angle, excuse me. So a triangle has 3 exterior angles, 1 at each vertex, okay? Same thing with a four-sided figure. Start with one side. This time I'll move around the opposite direction clockwise just to show you. So I'm going to extend it. Here's an exterior angle. Here is an exterior angle. Here is an exterior angle. Oh, that's a 3. And here is an exterior angle. So a four-sided figure has 4 exterior angles. And then your fifth or your 5-sided figure has 5 exterior angles. So again, just extend them and keep moving around either clockwise or counterclockwise. There should be 1 at each vertex. Now, again, the cool thing is all 3 of the angles, exterior angles for a triangle add up to 360. All 3, why am I having trouble with numbers? All 4 exterior angles of a quadrilateral add up to 360. All 5 exterior angles of a pentagon add up to 360. So it doesn't matter what the shape is. The exterior angles are always going to add up to a 360 for a convex polygon. Okay. All right. Let me just go like this. That's faster. So try these. Use the polygon exterior angle sum theorem to find each measure. All right. So here I have 1, 2, 3, 4 sides. So there should be 1, 2, 3. There's missing. I'm going to label it with an X, 4 exterior angles. Okay. So I know that the 4 exterior angles have to add up to 360. So that's my equation. All right, combine like terms. So 120 plus 81 plus 72 is going to give you 273. plus x equals 360. And then subtract 273 from both sides to get x is equal to 87. Here I have a 1, 2, 3, 4, 5-sided figure, okay? So there should be 5 exterior angles. 1, 2, 3, 4, and then you're missing 5th. All 5 angles, let me start with 73. It doesn't matter what you start with, but 73, then I'm going to go to 66, then 90, then 56, plus your unknown, add up to 360. All right. So when you add up all of your like terms, you get 285 plus x equals 360. Subtract 285 from both sides, you get x is equal to 75. All right. All right. And the last problem for class today. Oh, let me get my mouse to pull it down. It says, what is the measure of an exterior angle of a nonagon? So what is the measure of an, meaning 1, okay, of an exterior angle of a regular nonagon? Okay, so what do we know about the exterior angles of a nonagon? The sum of the exterior angles is what? It's 360. So sum of exterior angles is equal to 360. All right, if I want each exterior angle, well, since it's a regular nonagon, that means that all of the exterior angles are going to be congruent. And since there are 9 of them, I just take 360 and I divide by n. All right, so 360 divided by 9 is going to give you 40. Okay. All right, so last thing I want to do for this lesson, I'm actually going to scroll back up to the top. If maybe you have room up in the margin, I'm going to just kind of write down the 4 formulas that we learned in this lesson that you need to know. Okay, so sum of interior angles is equal to n minus 2 times 180. And then each interior angle, and this is only for a regular polygon. I'll write regular in parentheses. If I'm looking for each, then I do n minus 2 times 180 divided by n. All right, so that's for the interior angles. Now for your exterior angles, the sum of exterior angles is equal to 360. If I want to know each why did I put a period there? Exterior angle, and again, that's only for a regular polygon. That's when you do 360 divided by n. And again, n stands for the number of sides or the number of angles because they're the same. Okay. All right, guys, so there are some extra practice problems if you're looking for extra practice and review. So if you keep scrolling down, you do have some extra practice problems that you can give a shot, all right? But that is it as far as your notes are concerned for lesson 7.1. So I'll see you back here for the next lesson. Bye.